Let me record the session. And perfect. All right. Okay, so if you can't hear me, just give me a heads up. So this evening we will cover probability distributions. Okay, so we're moving on to the next learning unit. So I believe this is learning unit 6. So last week we covered learning unit 5, which is basic probabilities. Okay, so this builds on that. And so what this actually covers is, let me just share my screen to help give you a better idea. Yeah. Just let me know if you can see this whiteboard. It says binomial distribution on the right in a block, and then it says once a week a merchandiser replenishes, etc. Yes, it's the first bit. Great. Okay, Adrian, I don't know what chapters. If you give me a second, I will let you know now when I open the textbook. Okay, so probability distributions, it's chapter 5 of your textbook. All right, and that's page 143. Okay, let's see where we are. I'll come back to chat, see if any questions. Bigger, sure, I'll make the board. Let me just zoom in. It does blur the writing a bit, which is not ideal. Yeah, I don't like it. The resolution gets messed up here. Sorry. It's a bit blurred. Kalisha, is it okay? Or do you want me to go back to how it was? How is that? I will read it. Okay, yeah, happy with that. All right, okay. So, but I'll read it out to you just to help. Okay, so in this section, in this learning unit, you're going to cover 3 probability distributions. Now, what is a probability distribution? All right, so a probability distribution, it's a very, you can think of it as a function or a specific equation that you can use to calculate probabilities. All right, now you can use it for certain circumstances or problems, should I say. For instance, for a binomial distribution, it comes in very handy when the only possible outcomes are a binary outcome. What do I mean by binary outcome? Well, that means you can either be one or the other. So there's only 2 possible outcomes. So for instance, you can either answer yes or no. You can answer true or false. Someone can buy something or not buy something. All right. It's only 2 possible outcomes. All right. When that's the case, and when each trial or experiment is independent. Now, what do I mean by that? Okay, it sounds a bit fancy. Just think of it like this, okay? The example I mentioned earlier is you buy a product, you don't, all right? Now, I could go into the store and I could decide whether to buy this product or not. Then Adrian goes into the store after me, and then he decides whether to buy it or not, okay? Kalisha, you go into the store, so there's 3 of us now. You're the third person. You go into the store and you decide whether to buy the item or not. Now, whether I buy the item or not doesn't influence whether Adrian buys the item, and whether Adrian buys the item or not also doesn't affect you. So all of us, we're independent, okay? So those 3 experiments, all right, the 3 of us, we're independent of each other. We don't influence whether the other person buys the product or not. Okay, so that's what I mean by independent experiments. So when there's only 2 possible outcomes, and when each trial or experiment is independent, then that is a binomial distribution. And you can use an equation, which is given to you in your formula sheet, to work out probabilities. Okay, do you understand that example, what I just mentioned about independent trials and two possible outcomes? Does that make sense? Perfect. All right. Perfect. So, fantastic. All right. So we actually use this distribution in the real world. It comes in very handy because, as you can imagine, there's a lot of problems, and especially business problems, where the outcome can either be a yes or a no. Okay, you buy a product, you don't, and they want to work out basically the probability of maybe 10 customers buying the product or 50 customers, etc. And a binomial distribution comes in handy for that. All right, okay, so let's use that example for this problem. Okay, so this is actually taken from your textbook. It's not important what page it is because I'm going to work through this entire problem with you in the session. All right, so what this problem says is once a week, a merchandiser replenishes the stocks of a particular product brand in 6 stores. All right, so this part here is going to be important. 6 stores. All right, 6 stores for which she is responsible. Experience has shown that there is a 1 in 5 chance that a given store will run out of stock before the merchandiser's weekly visit. Okay, so what happens is the merchandiser goes to 6 stores, okay? And each of these stores can either be out of stock or have stock. So it's only 2 possible outcomes, and there's a fixed number of trials. That is, there's 6 stores, okay? So there's 2 possible outcomes, there's a fixed number of trials, they're independent of each other, just like how I mentioned earlier, the example. So that is a key giveaway that you need to use the binomial distribution. So it's very important that you are able to identify when to use the binomial distribution. I know I have it written out here, but in the exam, you won't be given this. You'd have to determine whether to use a binomial distribution or not. And you do that by looking at those points I mentioned earlier. Are there only 2 possible outcomes? If that is a yes, then you would tick that. Are there a fixed number of trials? Well, there's only 6 stores, so yes, you tick that. Are they independent of each other? Yes, you would tick that because each of these stores are also independent of each other. So that's a binomial distribution. So the first question is, which probability distribution is appropriate and why? And we've just answered that. Okay, so the answer for that is a binomial distribution and for the points that I just mentioned. Okay, so it's not any calculations involved, it's just basically stating the theory, all right, as to why you would use a binomial distribution. Now, question B all the way to E does involve calculations. So if you can, please do get your calculator out and have it ready because we're going to work through this together, right? And it's going to be practice for you to use your calculator on this one. So the question for B is, what is the probability that on a given weekly round, the merchandiser will find exactly 1 store out of stock? Now remember, there are 6 stores, okay? So let's put dashes for each store. That's store 1, store 2, 3, 4, 5, and 6. Now what they're asking is, what is the probability that 1 store would be out of stock? All right, so for instance, this store could be out of stock and the rest of them could be they could have stock, right? So it doesn't really matter whether this one it could be this one and then this one has stock. So all we're interested in is one of these stores being out of stock. So remember, there's only 2 possible outcomes. You can have stock or you can be out of stock. All right, now a giveaway of what you want the event to be is in the question. The question is saying out of stock. So you're interested chance or probability that a store does not have stock. No worries. Okay. All right. So what you need to do is you need to let a random variable, and the random variable is just some unknown variable, X, or something you want it to, some letter that you want to represent what you're interested in working out. The general convention is X. We let X represent what we're interested in measuring. So we let X be the event that a store is out of stock. So X is the event that a store is out of stock. All right, now, once we've created this X, then to express this as a probability becomes a bit easier, because what they're asking us for question B is they're saying, what is the probability that one store is out of stock? So what they're asking us is, let me write this out, just get my pen. All right. We're saying, what is the probability? Oops, I'm gonna text, there we go. Probability we represent by P as we did last week. They want us to work with the probability of X equals to 1. So basically, what is the probability of one store being out of stock? Okay, does that make sense? Does this expression make sense to you? Or is anything unclear? I'll go through it again. Just let me know in the chat. Makes sense. Perfect. Fantastic. Okay. Yes. Okay. You joined a bit late. Sorry. But ahead. I'll try and make a recap in the end. Okay. But I need to work through this problem now. All right. So let's get back to this. We're gonna work a probability of X equals to 1. And just like I mentioned earlier, for binomial distribution, we can use a specific equation to work this out. And there's the equation here. It's in this block. It's given to you in your formula sheet. All right. It's given to you in your formula sheet, so you don't need to memorize it. Okay. So the formula, if you can't see it, I'll maybe write it a bit bigger here on the left. Okay. So it's N. Let me write with this pen. Give me a second. It is N C X. Okay. P to the power of X, 1 minus P to the N minus X. So I know it's a lot of letters here, but I'll take you through each of them and what they mean. Okay, so the N that you see in this formula is the number of trials. So it's how many stores do we have? Well, we have 6 stores. So your N is 6. Right. Now, the P in this equation is the probability that a store does not have stock. So whatever your X is, okay, so in our case, our X is the event that a store does not have stock. So P is the probability that a store does not have stock. And if you read the question, it tells you what that value is. It says experience has shown that there is a 1 in 5 chance that a given store will run out of stock. So 1 in 5. So that means P is equal to 1 over 5. You can write this as a fraction or as a decimal. It's really up to you. Either way, you have to plug it into the formula now when you use it. So what we're going to do now is to work out the probability of X equals to 1 is using this formula here. And all we do is where we see X, we put 1. So wherever we see X, we're going to put a 1. Wherever we see P, we're going to put this value here, 0.2. Okay. And where we see N, we're going to put 6. Now you may be thinking, okay, what about this big C? What do we do for that? Well, this C is what we did last week. This is the combination. Remember the counting technique? It's that function above your division button on your calculator. Look at your calculator, above the division button, you'll see something as NCR. That's what the C is. You're just using that function there. So in our calculator, what we're going to do is we're going to use this function for this part here, this NCX. But instead of, if you look at your calculator as R, but instead of R, we're just using X. It doesn't matter what the letter is. What's important is the number that we're going to substitute there. So for our problem where the X is 1, we're going to have our N, which is 6. So all I'm doing now is I'm following with this formula. So it's N is 6. So I'm going to have 6C, and our X is 1, if you look at here. So it's 6C1 times, because between each of them there's a multiplication, times P, all right, to the X, times 1 minus p to the n minus x. Now, all you need to do here, all right, so we're going to enter this in our calculator, all right? I'll do it with you. All right, so have your calculator out. What we're going to do is we're going to enter this part out here. Okay, this n, the 6c1. So with your calculator, you press 6, you press shift, and you press the division button. And then you should see in your calculator the 6 and the c already. Then the next thing you're going to type is the 1 after it. So you press 1. Okay, so we should have all of this now in our calculator, in the display. Then it's multiplication, so we press times. Now our p is given to us. We've established this as being 0.2. So instead of the p, you're going to type 0.2. So times 0.2. Okay. Did I cut out everyone? Just checking. No. So okay, Kai, I think the reception is on your side. Okay. Yeah. Okay. So Kai, for p in this formula, where you see p, you put in 0.2. Okay. All right, everyone. So everyone should have, on the display of the calculator so far, you should have 6. You should have c1 times 0.2. Let me see the chat. Okay, cool. So far, everyone should have this in the calculator. Now, the next part is this x and the exponent. So remember, the button to get the exponent, you should see this button here on your calculator, which is an x with a block here. So that's the button you'll press, and you'll see the cursor would move to the top here. If you press that, right, you'll see the cursor puts like this thing here, this copy, which is telling you that it's ready for entering the exponent. So for the exponent, remember your x is 1, okay? That's what your x is. So wherever you see x, you put 1. So you should have 1 in your calculator now. All right, you can close the bracket. So you should have this 1, close bracket. All right, now we're back down to the bottom here. See, that's multiplication. All right, now you're going to open bracket by following this. Open bracket. Then it's 1 minus p, 1 minus. Now instead of p, remember, 0.2. Close bracket. And then you're going to go to the exponent again. Yes, Krisha.
Daryl, sorry, man. There's something wrong with your cursor because when you're talking, we can't see your mouse moving, so we can't see you like pointing to the stuff. So it's just getting a bit difficult to follow. Like normally we can see your mouse moving around. I don't know if it's because of the size, because of you changing the size that's happened.
Okay, you know what? Let me just try something else. Give me a second.
Okay.
Thanks for that.
Okay.
Okay, if I get cut off, just bear with me. Okay, I'll give me about a minute and I'll try and reconnect, but just hold on. Okay, I'm gonna go back to. Can you see the cursor now?
Perfect. Perfect now.
All right. Okay. All right. So okay. So where were we? In the calculation, everyone should have this so far. Should have the 1 times, then the bracket 1 minus p. This is 1 minus 0.2. Close bracket, and then we go back to the exponent here, and it's going to be n, which is 6 minus your x, which is 1. Did everyone manage to enter this in a calculator? Let me know if you didn't. Press equals to and let me know what value you got. If you're stuck, I'll come back to this. I'll redo it. Yes, fantastic. Yeah, that's it. 0.39. Well done. Well done. Very good. That's it. So that's the answer. That's the answer for B, 0.39. Okay, so 0.393, or in other words, 39.3%. Okay, so let me just clear this, and then I'll come back to it. All right, let me get back to question C. So now we're going to do question C, all right? So with question C, we've answered B, which is 0.39, or in other words, 39%. Now we're going to do question C. So question C is, what is the probability that at most, okay, at most, this is very important here, that at most, 2 stores will be out of stock. Now, when we say at most, that means we can't be more than 2. We can't have 3, we can't have 4. 2 is the maximum. At most means 2 is the maximum. So we have to consider everything from 2 and below. So 2, 1, and 0. Remember, we can't have the case with 0, where x is 0. That means no stores were out of stock. All right, that is the case of 0. So remember, 0 is included. So make sure you understand what at most means. At most, this means you must include the upper limit, which is 2. So that means x can be 0, 1, or 2. So what they're asking us for question C is they're asking us for the probability of x less than equals to 2, because it means 2 is included as well as everything below 2. Does that make sense, everyone? Anything unclear there? Did I lose anyone? All clear? Good. Okay, fantastic. So the difference between this probability and what we worked at earlier, remember the previous question, question B, is we worked at probability of x equals to 1, right? Now this is it's a point mass function. You don't really need to know the term, but what I'm trying to say is here, we're just working out the probability of a single x value. But when you have an inequality like this, less than or equal to, that means you need to work out not just the probability when x is 2, you need to work out the probability of x of all the values of 2 and below it. So you need to work out this probability when x is 0, you need to work out the probability when x is 1, and then you need to work out the probability when x is 2, and then you add them up, and that's the final answer. This is a cumulative probability. Cumulative means you're summing them up, okay? So you actually need to work out probability where x equals 0. Then you need to work out the probability when x equals 1. And you need to work out the probability when x equals 2. You need to work out all of them. And then your final answer is when you add all of them up, okay? And that is the answer for this probability here, okay? It's by adding all of these up. And how you would do each of them is how we did question B. For this one, instead of x being 1 in that formula, you'd have x equals to 0. For this one, we've already worked this out. You've put this in the chat, this probability of 0.39, okay? And then this one, instead of x being 1 like before, you're going to put x equals to 2. But everything else is the same. Your n does not change. Your n is still 6. Your p is still what we had in the formula before, which is 0.2. All right. Now, I'm not going to expect you to work each of them out right now, but I'll do it for you, okay? So the probability of x equals to 0, I actually have it somewhere. Give me a second. And I don't know, it's 0.2621. I'll write it down. It's 0.2621. Let me check that again. 621, and then x equals to 2 is 0.2455. 0.248. 0.2458. And this one we worked out earlier. You have that in chat. Okay. So you do each of them like how you did the previous question. Each one you got to work it on your calculator. For x equals to 0, you'll get 0.621. For x equal to 1, you'll get this. And we add them up. If you add it all up, your final answer will be, tell you now, 0.9011. 0.9011. Let me just double check that. So yeah, I'm not going to go back and forth because before there was a cursor problem. As Kalisha pointed out, I had two screens, so I could just go between the two. So just bear with me if I'm toggling between the two of them. Okay. Okay, so does this make sense, everyone? When you have a cumulative probability, that means when it's an inequality like this, less than equals to, you got to work out everything from the upper limit to below it and add them up. Good. Okay. Fantastic. Fantastic. So that's question C. Okay. That's question C. Now, question D, I'd like you to give this a shot. Maybe work out and put the answer in the chat. So I'll give you a clue here, right? So read the question D. It's saying, what is the probability that no stores will be out of stock? So my first question to you is, what is the X value for question D? The question is, what is the probability that no stores will be out of stock? So what is the X value? Maybe put that in chat. Remember what X is. X is the event that a store is out of stock. So fantastic. Yes, that is exactly it. Well done. So for question D, they're asking us to work out what is the probability that X equals 0. That's what they're asking you to work out. And we just did that in question C. I wrote that out. I think it's like 0.2621. I'll just check. It's 0.2621. Yeah. So that answer is 0.2621. Well done, everyone. All right. Question E. All right, the last question here. What is the mean number of stores out of stock each week? Okay. Sorry, I said I have a sip of something. All right. So what they're asking you for question E is the average. Mean means average. So what is the average number of stores out of stock each week? You don't need to memorize the formula for the average. When you have a binomial distribution, if you look at your formula sheet, the mean, I think it will be denoted in your formula sheet as x bar. Okay, the average for the binomial distribution is n times p. Okay, you don't need to memorize the formula. It's given to you. So all you need to do to get the average is you multiply your n times your p. So there's your n, which is 6, and there's your p, 0.2. If you multiply them out, you should get 1.2. That's what you should get. Now, let me just double check. Yeah, 1.2. So to give you some sort of intuition of why this formula actually works with the mean, let me ask you this question, all right? If the probability, oh wait, let me give you a better question of flipping a coin. Let's say I flipped a coin 4 times, right? I flipped a coin 4 times, right? I want to know on average, what would be the number of tails I can expect? If I flipped the coin 4 times, what would be the average number of times I would expect tails to pop up? Just take a guess. Go with your intuition and just put it in the chat. Flip the coin 4 times, on average, how many times do I expect tails to pop up? Yes, everyone is just using your intuition. And the thing is, how you got that 2 is basically you use the same formula here. Your n is 4 you got 4 trials. That's what your n is. Your n is you got 4 trials. Okay. Now you all know, even if you didn't even think about it, intuitively you know that you have a 50% chance of getting a tail. So your probability of getting a tail, your P, is a half, which is 0.5. And how you got the 2 is you took the 0.5 and you multiplied by 4. So you multiplied your P times your 4, and that's how you got 2. See, so does it make sense why this formula kind of intuitively makes sense? I used the example of the coin, and you actually didn't even use the formula. All right, fantastic. All right, so that's why the average is determined by n times p. Okay, so that brings me to the end of the binomial distribution. Okay, so I'm going to close this whiteboard, and I'm going to move on to one more distribution that I'm going to cover this evening, which is the Poisson distribution. I'm just going to close this. There we go. Okay, let me know. Let me just check if I'm sharing. Okay, let me know if you can wait. Yeah, let me know if you can. Can you see the cursor? I'm scribbling here before I proceed. Oh, okay, fantastic. All right. So we've covered the binomial, and now we're going to cover the Poisson distribution. All right. Now, the difference between the Poisson distribution is and the binomial is that for Poisson, you're counting the number of times something occurs in a given interval. Now, that interval can be time, or it can be the length of something. So let's look at this question here to kind of give you an example, right? So it says a web-based travel agency uses its website to market its travel products, which are holiday packages. So the agency receives an average of 5 web-based inquiries, so 5 inquiries per day, right, for its different products. So you're given an average, and that average is based on a time interval, that is per day, all right? Now, here, why it is a Poisson distribution is because you are given an average for a fixed time interval, right? And each basically experiment, or for this example, an inquiry is an experiment. Okay, so if I phone this agency and I want to inquire about holiday, then Kalisha phones later on in the same day, and she also inquires about the holiday. We don't, whether I call to inquire doesn't affect whether Kalisha inquires. We're independent of each other. So that's another example of independent trials. Right? So there's an average for a given time interval, and each experiment or trial is independent of each other. So that is why you would use a Poisson distribution. All right. So the moment we know that we need to use a Poisson distribution here, then you need to know that you need to use this formula here. This formula is given to you. You don't have to memorize it. I'll write it a bit bigger in case you can't see. It's the probability of x, okay, equals e to the minus a times a to the x all over x factorial. All right, that's the formula. If you look at your formula sheet, sometimes instead of a, they use lambda. They use this Greek symbol. But just know that lambda and a is the same thing. Okay, just a symbol difference. But what that symbol is, it's just basically the average that you're given in the question. The average of 5 in this question. So that means this is 5. So in that formula, you're going to use 5 where you see a. All right. Now, let's get to the first question. Question A. All right. Question A is, what is the probability that on a given day, okay, so on that same time interval that we're working with. So that average is based on an average per day. So they're asking us to work with the probability of something based on that same time interval, which is a day. What is the probability that on a given day, the agency will receive only 3 web-based inquiries? So just like we did for the binomial distribution, we need to let a random variable, x, represent what we're trying to measure. So we're trying to count. What are we counting? We're counting the number of inquiries per day. So X is equal to the number of inquiries per day. And that's what our X is. So in question A, they're asking us to work out the probability of X being 3. What is the probability of X equals to 3? And that's where we're going to use this formula here. Where we see X, we're going to put 3. And where we see A, we put 5. And that's all we need for this formula. So we'll do this in our calculator now. Okay, so what we'll do is, let me just make sure everyone's off stat mode. Okay, so everyone, you can press mode in your calculator and press the option comp where you see COMP. Press that, which is option 1. All right, so we're all off stat mode. So what we do here, all right, we can use the fraction button because we have a fraction here. And the fraction button, everyone should see this block here with a division and then an empty block here. That's your fraction button. So you can press that and you'll see in your calculator you have a fraction. Now on the top, we're going to type this, what we see here in the numerator, e to the minus a. Now, e in your calculator is, if you look for the button where it's ln, it's on your right of your calculator. Okay, it's like the third from the top, you should see ln. If you look above the ln, you'll see this e to the block. So we want to access that e. So how we would do that is you press shift and you press this ln button here, and you'll see your e will be input into the calculator with a block. So you should see e with a block here. Okay, now in that block, what you're going to enter is, if you're following this formula here, is we're going to put in our minus a. Right, now a is 5. So what we're going to do is we're going to type minus 5, and you'll see that your calculator would have this e to the minus 5 so far. Okay, yeah, e to the minus 5. Now, be careful of this part here, because I've seen other students make mistakes here. What happens is you start typing the rest of the values, but your cursor is still on the exponent. You need to bring the cursor back down. And how you do that is you press right, and then you'll see your cursor moves back to the bottom. Okay, now you press multiplication because there's a multiplication here, and it's times a, and now a is 5. Okay, so you're going to type 5, and we're going to go back to the exponent here. So we'll press the, as we said earlier, the x with the block, and that'll take you to the exponent part. You have times 5. See the chat. Kalisha, you move right, the cursor, that big blue cursor, move it right, and the cursor would move back down to the bottom. Cool. Right, so we're all on 5, and then we're going to press this exponent button. Right, if you press that, then you're going to enter the value for x, which is, our x value is 3. Okay, 3. And now you move the cursor to the denominator, because we've entered everything in the numerator. We've got everything we need in the numerator. Now we need to enter the denominator. So it's x factorial. Okay, so your x value is 3. And I say factorial, that's what the exclamation mark is. The exclamation mark is factorial. I'll show you how to input in your calculator. All right. Once you move your cursor down to the bottom, if you want that exclamation mark, all right, everyone should see it. On the right of your calculator, you'll see a button that's x to the minus 1. All right. Above that, you'll see an x with the exclamation mark. So you need to access this button here. So you'll press shift and this button here. Shift that button, and you'll see in your calculator you'd have this, the exclamation mark, and then hit equals to. Oops. Yeah. Let me know once you've done that. You can write the value in the chat. If you're stuck, if you've got an error in your calculator, just let me know. Yes, well done. Yeah, that's right. 0.14. That's right. That's the answer. 0.14. So it's 14%. So there's a 14% chance that you would have 3 inquiries in a day. 14%. Well done, everyone. All good? Okay. You're getting used to using your calculator. Sorry, I got lost a few steps, but sure. Okay, just give me a shout. We're going to have a little bit more practice for the next two questions, so that's fine. Okay, so for A, it's 0.14. All right. Now let's move on to question B. So I'm just going to clear this out. Right. Okay, we're going to move on to question B. Okay, question B. All right. What is the probability that on any given day, a given day, the travel agency will receive at most 2 web-based inquiries for travel packages? So read this part here carefully, okay? What is the probability that on a given day, the travel agency will receive at most 2 web-based inquiries? So I'm going to give you 3 options and you need to tell me which one is the correct one, okay? Are they asking for this probability of x less than 2, probability of x less than equal to 2, or they're asking me for the probability of x greater than 2? So are they asking me for option 1? Are they asking me for option 2? Or are they asking me for option 3? Yes, that's right. Well done. They're asking me for this. Very good. It's very important that you're able to write it out mathematically, okay? Because everything you're going to do after this is based on that. Well done. I'm very happy to see that. So this is what we need to solve. Probability of x less than equal to 2. So this is the same principle of how we did the binomial probabilities. This is an inequality. This is a cumulative probability. So it means we need to work with the probability for x being 2. So we need to, these are the x values. X being 0, x being 1, and then the last one is 2. We need to work at all these probabilities. We need to work at all of these probabilities. And then we add them up. Whatever this is, whatever that is, we take all these values and we add them up. And that's our answer. Okay, just like before. So that means for each one, when x is 0, you need to plug it into this formula. Get a probability, write it out. When x is 1, the next value, you're going to plug it into this formula, get a probability, write it out. When x is 2, etc., in the formula, again, get a value and write it out. And then finally, once you get all 3 of them, you add them up, and that's your answer. So I've done the work for you. So basically, how you work at each of them is with your calculator. Now, we've done for question A, we've done x equals to 3. So just to check that you can do this calculation, all I want you to do is I want you to work out this probability here when x is 1. Try this out in your calculator now. So what I'm asking you to do is just work out one of them. I want you to work out the probability when x is equal to 1. Okay? Work out the probability when x is equal to 1, just to see if you can do it on your own now. See, I'm testing to see if you can use this formula. Okay, there's your A. Your A never changes. It's still the same average. The only difference now is your x is 1. So plug that in your calculator and get me the value and write it in the chat. Give it a shot. If you're stuck, let me know. But I really want to see if you can do it in your calculator. Okay, Arian. Yeah, okay, let's see. 3.3. Very good. That is it. That is the answer for x equals to 1. Nicely done. Very good. That is it. So the probability of x equals to 1 is about 3.37%. Kalisha, if you're stuck, please let me know. But okay, so from what I can tell, you know how to work at each of these probabilities. You've done it for x equal to 1. It's the same principle for x equal to 2. You just plug in 2 and you get the value. So once you get all three values and you add them up, the answer for this, I've done the working for you, so I'm just going to write it out here. But when you're studying and revising, you can compare your answer to what I'm going to write now. So the answer for this is, give me a second, it's 0.1247, 0.1247. You may get a slightly different answer, maybe by 3 or 4 decimals. That's okay because it's just a matter of rounding that's different, okay? But it should be in the same vicinity. So in other words, 12.47%. Double check that. Cool. Okay, so is everyone good at that? Anyone want me to go back and just go over something again in this question? Or are we all good before I move on to the next question, which is the last one for this evening, question C? Good, all good. Okay, all right. Okay. Then you just add. Yes, you add all of them up to get. Remember, this is a cumulative probability. This is a cumulative probability. So it means x less than or equal to 2 means you need to add up when x is 0, x is 1, and x is 2. And that's your final answer. Yep. So make some space on this board. Okay. All right. So the last question, question C, right? This one says, what is the probability that the travel agency will receive more than 4 web-based inquiries? So more than 4. So what they're asking me here is to work out the probability. Let's check some chat. 4. Yes, that's right. You can't include 4. Good, Kai. Hope I'm pronouncing your name right, Kai. So you're right. You can't include 4. So they're saying probability of x greater than 4. Now it's very important that you use the correct sign. You shouldn't use greater than equal to. That makes a big difference. Greater than equal to means you include the 4, whereas we're not including 4. More than 4 means you cannot have 4. Okay, now if you look at probability of x greater than 4, now because this is greater than 4, that means you need to look at all the values greater than 4. That is 5, 6, 7, 8. This doesn't stop. This goes all the way to infinity. Now, there is no way that you can work out all of these probabilities. Okay, it's just too many. All right, so now we need to use a little trick here to make it easier for us to actually work this out in a feasible amount of time. And that's using the complement rule. Okay, so I want you to pay very close attention to this, okay? The probability of x greater than 4, right? That means that is working on the probability of 5. So here, 5, 6, 7, all the way to infinity. Okay, we can't do this. So it's not feasible. All right. Now, we're going to use the complement rule to do this, okay? Now, to kind of explain the complement rule, let me use an example here, okay? If I say the probability of the box winning the rugby game is 80%. So the probability of the box winning, I'm just going to put box winning, is equal to 80%. Okay. Then what is the probability that they will lose? Give that a shot in the chat. That's the probability that they'll win. What's the probability they'll lose? Okay. Yes. Very good. Okay. How did you get that? You basically took 1 minus that. 1 minus 80% gives you the 20%. Okay. All right. So in the exact same, sorry, I miswrite this again. Okay, so probability of box is 80%. All right, 80%. So as you said, the probability of them losing is 20%. So that means, say I didn't know that the probability of the box will, the probability for the box winning. Say I didn't know it is 80%. Say I know this, but I knew that the probability of them losing was 20%. So I knew the inverse. So if I knew that the probability of the box losing, I'm going to put L there, was 20%. If I knew this, but I didn't know this, I could easily work this out using this, right? It's basically doing 1 minus the probability of them losing. Everyone agree on this? Does this make sense? Oh, good. All right. Now keep this example in mind for what I'm going to do now. All right. I use the complement rule to work out the probability of the box winning by using the probability of them losing, the complement of them winning. So in the exact same way, instead of working this out directly using this, I'm going to use the complement rule. So the opposite of this, right? Remember, this is the box winning. So the probability of them losing wouldn't be the probability, the opposite of that, which is x less than equals to 4. Remember, if you're not including it greater than 4, you have to include it when you're doing the opposite. Everyone agree on that? That makes sense? That's the opposite. Okay, that's the box losing. Very good, very good. So this is equal to 1 minus its complement. Just like how this is the box winning, this is the box losing. So this is equal to 1 minus probability of x less than equal to 4. Does that make sense? I'm going to put this in red, yeah. Does what I just wrote here, does this make sense? Everyone? Fantastic. Great, great. Well done. Okay, so that's the hardest part. So I'm going to make some space on the board here. Fantastic. All right. So for the complement, this I can work out. Pen. This I can work out. I can work this complement out in a reasonable amount of time because x less than equal to 4. All I need to do to work this out is I just need to look at when x is 0, 1, 2, 3, and 4, because it's only those values that are less than or equal to 4. This I can do in a reasonable amount of time. All right, this I can work out. And once I got this, once I work out each of them, all right, like we did earlier, that'll be the probability. If I add them all up, I'll work all of them up and I add it up. That's going to give me the probability of x less than equal to 4. Agreed? Just like how we did it earlier, probability of x less than equal to 2, you'd work out x0, x1, x2, and add them up. All good? Yeah, well done. Nicely. Okay, we'll be getting there. So that's how you work out the probability of x less than equal to 4. Now I've done this work for you, so don't worry about, I'm not going to ask you to work it out. I've worked out all of them. Okay, this is it here, each of them, and I'm going to add it all up. I'm going to get a value of 0.4405. So adding it all up is going to give me 0.4405. All right, and then all I need to do now to get this probability is I need to put this in to here. So it's 1 minus, so the final answer is 1 minus this 0.4405. And the final answer is 1 minus that, which is just about 0.5595. So it's 55.95%. Is equal to 55 0.95%. That's the final answer, percent. Does that make sense, everyone? Let me know if I lost anyone. Please do let me know. Oh, good. Fantastic. All right. Cool, everyone. That's what I wanted to cover today. So today, this evening, we covered the binomial distribution and we covered the Poisson distribution. All right. And next week, we're going to cover the normal distribution. That's next week. And then we will be done with this learning unit. Okay, so we just got one more probability distributor to cover, which is next week. And we're done with learning unit 6. Yeah, we're done learning unit 6. All right, everyone. If there's any questions, let me know. Otherwise, I think it was a good session. Thanks for joining. I hope you enjoyed it. I'm glad to hear that. Very happy to hear that. Okay, I'll make the recording available by tomorrow. But enjoy your evening, everyone. We'll chat soon.